Welcome. So, in this lesson, we are going to be looking at data visualization, which is the second phase of exploratory data analysis. And the libraries that we're going to be using for this phase, there are three libraries really that we're going to be using, and they are Plotly, Matplotlib, and Seaborn. Plotly, Matplotlib, and Seaborn. So, um, we're going to start off by importing these three libraries. Excuse me. Okay, so we're going to come here and say import. We're going to come here and say import. Okay, let's start by importing pandas as PD. We're going to import numpy as np. Those are the libraries for data wrangling and numerical computing. Let me zoom in a little bit. Then we're going to say import matplotlib, pyplot as plt. We're also going to import Seaborn as SNS. We're also going to import plotly.express as px. Then we're going to run this. So these are the three libraries that are needed for um, visualization, and we are going to be looking at them extensively today. We're going to be looking at Plotly, Matplotlib, and Seaborn, and how we can use each one of them for our data visualization needs. All right. So, before we can do anything really, the first thing that we need is the data. So we need data, and we're just going to be using a practice data, so that we can reproduce this particular all of the stuff that we're going to do in this session. For easy reproducibility, I'm going to be using a practice data set. I'm going to say data equals px.data.tips. So I'm going to be using a tips data set by Plotly. And if you check the head of that, this is what it looks like. This is what it looks like. So this is the data set that we're going to be using to learn how to make different plots. However, there is a particular chart that we're going to be using, which is line plot. And plot is actually best used for when we have time series data, like when we want to show the trend of a continuous variable with respect to time. And we don't have such data setting. We don't have anything along the lines of dates and stuff here. So I'm going to just randomly create one. So I'm going to come here, just below this div, I'm going to say randomly create date variable, date column. And how do we do that? Since we are going to be doing random sampling for the date, I'm going to firstly set seed to 23. So it's important that you do this so that you can have the exact same date outputs that I have to. That is what these random states will do for us. So I'm going to say data of, we can call it date, and that is going to be equals to pd dot to underscore date time, so that we convert that straightforward to date time, and we can make np dot random dot choice, and that's going to be pd dot, can get date range. I think pandas has date range, yeah, date range, and we can start from 2021 01 01 Then we can stop at 2021 12/31. That is December. And we can set the size of our, like the size of the entire thing, the size of this particular choice, the number of dates that we want to sample out of this randomly is going to be the length of our data. Now, well, this could be data.shape, then you say um, 0. Now, you might be thinking, why not just do pd.dateRange and pass it in? If we do that, we are only going to have a single order for a particular date. So we are not going to be having a kind of a situation where you have multiple stuff in a day, like multiple orders in a day, and that is exactly what we want. So if we come here and run this and see data.head, now we have this now, and we have these dates 2021, 2021, 08, 09, and stuff. So if I should come here and do data date dot value count, and I do this, so we see that there are days where we had 4 orders, some days 4, some days existed 4 times, some 3 times, some 1 time. So that's exactly what we want to achieve. So having put this in place, let's actually get to the visualization part. So I did all of this so that all of us can just have this same data set to work on. That is, we are watching this video, it's easy for you to just have this data set that we can just work on without having to import anything or have to drag some data in. But it does not mean you cannot do this with your own data set. In fact, after watching this tutorial, the smart thing to do would be to just try these things out on your own data set. So the first chart that we're going to be looking at is, we're going to be starting off with let's start with bar plot. That's the ideal one to start with, or bar chart. So how do we plot bar chart with, let's say, matplotlib firstly? So I can say matplotlib. So let's say what we want to plot, let me show that back to you again. We want to plot a bar chart of um, the average tip that is given by each gender, right? What's the average tip that is given by each gender? So to start with, when do we use bar charts? We use bar charts when we want to see how a continuous variable is distributed over some categorical variables. That is, how is tip distributed over gender, right? So what we are going to do is, for matplotlib, we are going to say plt dot plot. We can do something like this, like plt dot plot. And the way that would work is this: if you do plt dot plot for majority of the things, it works. But plt has dot bar also. Like, and if you do dot bar and you do x equals, let's just go in and say x equals data of what's going to be on our x-axis. What we're going to have on our x-axis is smoker. And what we are going to have on our y-axis is tip. And sorry, I should end this with a square bracket and end this with a square bracket. So if I should run this, we have an error. It says bar is missing one. Okay, yeah, not y, height. We can check the doc string here. So it says x and then height, not y. We can come here and say height. So if we run this, we see, okay, this should be data. Sorry. Perfect. We see this particular thing where we have our bar chart and this particular outcome here. So what we are actually seeing here is our bar chart, and if you can define the width if you want, you can do a lot of other things like to align it. And if it's a thing where there is a data, you can pass that in, which is in our case. But the reason why we are not doing that style is because for Seaborn, which is usually what you're going to be using if you are plotting something like this from Matplotlib, it is a cleaner and much more better solution. And here's what I mean by that. This exact bar chart, we can plot it with Seaborn. So I can come here and say SNS dot bar plot. Let me come here and say Seaborn SNS dot bar plot. I can say data equals data, x equals, our x is sex, our y is tip. So if I run that, you see that we have the same chart that we had up here. We have it here. But this is on a different axis. If you look at this axis here, you can see that it's different. This is kind of like sum, right? If I should come to this place and say comma estimator equals sum, this is not even sum. So this one like count, I guess. We can't even relate to what we are seeing. So if we say by default, this is mean, right? By default. So it looks like this in a way, but this is different and it cannot be count. This cannot be count plot. So in here, you are seeing a range that is different from what you are seeing here, but you see that the stuff is almost the same. So to be able to know for a fact what you are seeing and know that, okay, this thing I'm seeing is actually mean or median or whatever thing, for Matplotlib, you are going to have to come here and create it. You are going to create your own group by from scratch, then use plt.plot. Or you can still use plt.by if you want. So how does that work? I can come here and say temp underscore data is going to be equals to data of smoker, comma tip. You can go here and say dot group by, and I can say by equals smoker. Sorry. Yeah. No, this should be what? No. We are looking at different things. That's why this should not be gender. Should be smoker, since that's what we passed in here. That's why this was different earlier. So if we run this, we see very close to each other, smoker and tip, and the axis is still different. So we can come here now and say group by is smoker, and then we can say dot mean. So this one gives us the group by, and I can come here and say x equals temp underscore data dot index, and height is going to be data tip. So if I run this, it says mismatch between shape 1 and 2. So here we just do plt.plot, I guess. So it says unexpected keyword argument x. So let's check what dot plot takes. So it does not take, we don't need to pass in x or anything, just pass in this and pass in this. Okay. Oh, right. This one should not be data, it should be temp underscore data. And this should be plt.bar. Perfect. And we know for a fact now that we are seeing this chart here is the same one as this one here on the same scale, like on the same scale. And we know for a fact that we are seeing mean. So if I should come here and do sum and run this, this is what we are seeing. And if I should come here and change this to sum, we are seeing the same thing, like the exact same chart. So Seaborn and Matplotlib, they are the same thing usually, In fact, Seaborn is built on top of Matplotlib to serve as this cleaner interface, this very clean interface where you can just write you know beautiful syntax. You don't have to write too much to get the job done, right? That is what happens. So for majority of the things that you can use Matplotlib for, you probably should use Seaborn, except if that chart is not available in Seaborn. So how can we customize Seaborn and Matplotlib chart? So we can just do sns.set_style, and we can do dark grid, and we can come here and say sns.set_palette for color palette, and we can do also. And if I run that, then we run this, we're going to get prettier charts. Perfect. Then if I should run this also, we're going to see a prettier chart. So how do we put title on something like this? So we can come here and say plt.title, and we can say let's change this to mean so that we can say average tip. So this is going to be average tip by gender or by smoking habit. So we're going to see the title here. And if I want to fix the X and Y axis, I can go plt.x label. So that here is going to say smoker. Say smoker. And we have smoker here. And this side, I can add something here to say average tip. So I can say plt.y label. And I can say average tip. And if I run that now, we have average tip here. And these three things, I can actually copy it for Seaborn also. Paste it here for Seaborn, and it is going to work. So this is for Seaborn, average tip, like that. So this is to show you that Matplotlib and Seaborn charts, they are essentially the same thing. Like they are basically the same thing. And when you are plotting one, especially Seaborn charts, you are basically just plotting Matplotlib charts. Now let's see how to do bar chart in Plotly. So Plotly is a bit different from Matplotlib and Seaborn, and it is different in a way that it also gives us interactivity. Like if you've learned Power BI before, Plotly give you that thing where you can, over on your chart and get some tooltips and stuff like that. So if I should come here and say the way we plot charts in Plotly is px dot. If you do px dot bar, there's px dot bar. So you can say data underscore frame equals data. Our x is going to be equals to smoker. Then our y is going to be equals to tip. And if I should run, I mean, that is everything really. And I can run this. And what is going to return is going to be something that is really not that very pretty, because it's going to stack each of the records that we have on top of each other. The first time that you run Plotly, it might take a little while. Yeah. So this is what we're talking about. So this is for sum of tips, right? That you're finding here. But I'm going to see that you have all of these lines, these small lines on each other like that. So if you don't want that to happen, you can just use histogram. You can say px.histogram. So the way px.histogram is structured in Plotly, whenever you supply multiple variables, especially two variables, one categorical, one continuous, it knows automatically that you don't want to see an histogram, you want to see a bar chart. So if I should run that, can you see it gives me a clean bar chart, and I can put my mouse here and it gives me this two tip of sum of tips, like smoker no, sum of tip, like that. And by default, Plotly does sum as the level of aggregation. If I want to change that, I can say East Funk and say AVG. That is, I want to see average. So for average, this is what I'm seeing. Average of tips now. And if it is sum, it's a sum here, or not just pass it in at all. And how do we add title? I can say PLT dot for Plotly, you don't do PLT dot title, you just come into this bracket and say title, and I can say that title equals sum of, well, let's do average since we've been doing average. If we did we do average here? We should do average here. AVG and mean. Then here also we should do mean. Okay, this is already mean, so I'm going to run this, run for Seaborn again, so that it truly does average. Then title is going to be average tip by smoker. So if I run that, I get this output where we have average tip by smoker, right? So that is how you do bar chart basically in Plotly. And if you want to do something like a multiple bar chart, the way to do that would be to add one extra parameter for something like this. For Seaborn, it's going to be, I can come here and say EU or OE equals, so I could go maybe gender and, okay, I think it's sex. It is named sex and not gender. So can you see now there is this extra layer added to it, and this has turned this into a clustered bar chart. And I can do the same thing here, but not with EU. It is with something called color. I can say color equals sex. And if I run that, I get this like stacked bar chart. If I want it to be clustered like this, I can come here and say bar mode, and I'm going to say group. So if I run that, I have this thing that looks like this one. So there are a lot of customization that you can do. You can come to each of their documentation and do Seaborn documentation. There is Plotly documentation. You should check them out, each one of them, and you are going to see majority of the things that we didn't even cover in this one. So next chart to look at is going to be let's look at line chart next, or scatter chart. Let's look at scatter chart. Scatter chart. And since scatter chart is available um in both Matplotlib and Seaborn, I might just plot only for Seaborn. Or there's no point. Let's plot both. So PLT dot scatter like this. And to start with, what do we use scatter plot for? So we use scatter plot to show two things, correlation between two continuous variable, like the relation between two continuous variable on a linear space, like are they going together? How is variable A, like a unit increase in variable A, how is it affecting variable B? The other thing is clustering. We can also use scatter plot to look at clustering. So if we want to look at relation between tips and total bill, can come here and say data total bill like this. So if we run that, we see this. So we see this kind of like a positive correlation where as one is going up, the other is following too. So that is what happens inside a scatter chart. Now, If I want to plot something like this using this is matplotlib, so let's add it here. Say matplotlib. If I want to do that for plot cborn, I can come here and say sns dot scatterplot, and data is going to be equals to data. X is going to be equals to which one is on X here? That is tip, and Y is going to be equals to total bill. And if I run that, we have the same chart as this one. We have it here. However, we can add something like apart from seeing that there is a like this positive correlation between both, where this thing is just going up, we can add U to it and see if there is a cluster behavior. So we come here and say maybe by day, and we run this, we see that there is no pattern to how people are um, tipping or buying on daily basis. If we do time and yeah, there is not much pattern, but the little that exists is that dinner dominates, right? Dinner dominates, and but it is not really that much of a pattern. If there is a pattern, it is going to be clearly visible for us to see. Let's see something else. And we can try sex and then smoker also and see. Can come here and try. Where is it? Can do maybe sex. I think male actually dominates in a way. Like lady, female are much more centered around this point. But it's not something that you can see obviously. So if it's an obvious cluster behavior, it is going to like dominate. You're going to see it very well. So let's look at for Plotly, how to make this kind of plot with Plotly. So we can come here and say px dot plot px dot scatter, and we can say data underscore frame, and that's going to be equals to data. X is going to be equals to tip. Y is going to be equals to total bill, and if we run that, we get the same thing that we saw earlier, which is this. However, we can add our color, and that is going to be equals to which one did we set for a sex. So we can run that and see the exact same thing that we saw earlier. So that is how you plot something like this with Plotly. So let's proceed to the next chart, which is going to be line plot. And like I mentioned earlier, we use line plots to visualize the distribution of a continuous variable over something like a periodic table, a periodic variable, a time variable. So we can do something like SNS dot, let's do cborn. We can do SNS dot line plot. Say data equals data, and x is going to be the time variable, date, and y is going to be maybe something like total bill. And if we run that, we're going to see that we have this particular movement, where we just all this up and down like that. That's what we have. And if you kind of like get this group by kind of thing where you can have temp underscore data equals data like this, date and total bill, and you can do dot group by like we did at the top earlier. But in this case, our by is going to be date and dot sum. So we get total sum per day. Then I can come here and say temp underscore data and x is going to be equals to temp dot index and the y is going to be equals to total bill. So we should run this now. We're going to get something cleaner where each day is just occurring one time and one time alone. So we see that we sold the highest on this particular day, right? And every other day is just around this area here. So let me show you. Let me just copy the. Okay, let me come to this place and show you for Plotly. It's going to be easier to look at on Plotly. So I can say uh, px dot scatter dot line px dot line, and I can say data underscore frame. That is going to be equals to temp underscore data that we created at the top. Then we can say x equals temp underscore data dot index, and our y is going to be equals to um, total bill. And if we run that, I can say we have a chart that looks almost like this, exactly as this actually, just bigger. And each day, we're going to say that on this day, I don't know what day this is, but on this day, we made our most total bill of 59.56. And this other day, like they are just very small, 43 dot like that. So that is how we plot line charts in Plotly. So the next chart that we're going to be looking at is histogram. So what do we use histogram for? We use histogram to check the distribution of a continuous variable. Check the distribution of a continuous variable. So I'm going to do cborn. So for cborn, we're going to say sns.histplot, and you can say data equals data. So let's say we want to check how total bill is distributed. So we can run this and it shows us this particular distribution like this. And if I wanted to do like this normal kind of thing that it gives us this line on top of it, I can add a variable that say a parameter that says KDE equals true. So we can see this particular thing that wants to that help us to check whether this thing is normally distributed. And one of the things that you use histogram to check also is normal distribution. So to check the distribution of our continuous variable. And another thing that let's check for Plotly. So for Plotly, we are going to say px dot histogram data underscore frame equals data. Then x is going to be equals to total bill. If we run that, we are going to see this histogram here, right? And it looks almost exactly as what we are seeing here. So that's how you make histogram in Plotly. So another thing that we can look and what we use histogram to do really, what we use it to do is for checking the distribution of a continuous variable. And we can also like tell the number of bins that we want, like the number of bins that we want. So if I should come here and say comma comma bins equals 5, and I run this. Now we see 1, 2, 3, 4, 5. So everything is squeezed within 5 bins. And if I want it to be, say, 10 beans, everything is squeezed within 10 beans. If I want 20, everything is squeezed within 20 beans. So it depends on how you want to look at it, right? So the same thing can be done here. You can actually do, I think it's called n beans in Plotly. So if I do n beans of 5, and I run this, like everything is distributed across 5 beans. So that is, let me just leave that to 20 and run this, and we see our outcome here. So that is box plot. That is histogram for you. So let's look at box plot. The next chart that we're going to be looking at is box plot, and we use box plot for almost the same thing that we use histogram for checking the distribution of a continuous variable, just how a continuous variable is distributed. So how can we do something like that? The way to do something like that is by in Plotly, in Seaborn is to say SNS dot box plot and say data equals data, and we can go x equals total bill. And if we run that, we get our box plot. And if I switch this to y, it displays it horizontal vertically. The same thing that you were seeing. And if I add one more variable, if I say x equals smoker, what this means is I want to see the distribution of total bill for each gender and for each smoker. So I see smoker is how total bill is distributed for people that don't smoke and how it is distributed for people that does smoke, right? So we see how the median is almost the same, but the range to median is larger. That is, majority of the data points are around this particular median range for smokers, right? So that is how you make a box plot in Seaborn. So if we want to make the same thing in Plotly dot in Plotly, so we say px dot box, we say data underscore frame equals data, x equals x is going to be equals to smoker, y is going to be equals to um total bill. So if we run that, we have the same thing that we are getting here. And you get to look at the Q1, the Q3, the median, and all of that for box plot. So there are a lot more other charts that you can look at. Okay, there is also pie chart. There's pie chart, and how can we actually plot pie chart um in pie chart? There is no pie chart in Seaborn. So how can we plot pie chart in Matplotlib? So for example, the temp data that we have, which shows, oh, let's create a new one. So these are our data dot add, data dot add. So you cannot pass a long data into a pie chart. It has to be summarized, especially for for Matplotlib. So let me add this here and say pie chart. So we're going to come here and say Matplotlib. And how do we fix that? Firstly, let's say we want to make a pie chart of um, day of the week and the tip that was given on that day. So we're going to say temp underscore data equals um, data day. I think yeah, day. Then tip. Then I can come here and say dot group by again. By is going to be equals to day. Then we're going to do dot sum or dot average. I'm sorry, dot mean. There's no dot average in pandas dot mean. Then we can call plt dot pi, and we can pass in our you see the two things that this guy takes is the x, the two important things, the x and the labels. This is our x is going to be in this case temp underscore data of tip, and our label, yeah, labels is going to be temp underscore data dot index, like this. And if I run this, see, we have each of the stuff. And this is one of the reasons why pie chart is a very terrible chart. So if you should only use pie chart if you have the magnitude of difference between each of these things, like it's obvious, it's very, very obvious. One, for example, if I change this to sum, let's see. If I change this to sum, now like this is a case where you would want, this is like one of the cases where you'd want to use a pie chart, because the difference between each of the segments are very, very large. And that's not even completely true, because if I tell you which one is bigger between Saturday and Sunday, it's still a bit tricky to know which one. So you want to be extra careful when it comes to pie chart. So another thing that we can add is we can actually add autopcity, so that is going to add percentages for what we are doing. So I can add percent, then 1.1, say f, then one more percentage. And if I run that, yeah, so I'm getting each of the percentages. So this is the biggest one, that's 5.6%. Then I can clean up this upper part by adding plt.title and saying pie chart of sum of tips. So that cleans up that particular upper part. So for the last one to check in this series is going to be Plotly pie chart. So it's just px.py. I'm just a data underscore frame. We don't need to do any extra work. Because data values equals tip, and um labels or names. Okay, names equals day. And if we run that, we have our output exactly like this one. So yeah, that's the last one we're going to be looking at. So in the next one, we're going to see some advanced chart and advanced plotting technique, like fixed size, like subplots, how to make multiple plots on the same axis, and stuff like that. So see you in the next one.